How you doing, everybody? Greetings and welcome to 8bits in the Basement. Now, this is an episode I've been waiting to do for quite some time, and I'm looking forward to it. Around Christmas time, I got myself an Atari 7800, and I managed to fix it up. It's working away great, so I'm delighted with it. And in order to test it out as a 7800, I bought myself this 7800 cartridge, which contains the game Jinks. Now, Jinks isn't a great game. It's confirmed by many to be probably the worst game that was written for the 7800s, right up there with E.T. for the 2600, from what I've read. But what I want to do is, I want to see if I can open this cartridge up, preserve it as best I can, so that it can be put back to the way it is right now, if needs be. But what I want to do is, I want to modify it in such a way that I can program up a ROM chip and put it in to run different games. Not to make a multi-cart as such, but to make a kind of a PCB that can take different ROMs and be set up in different ways to try out the library of games that are available on the Atari 7800. So there's a little bit to it. It's not all that straightforward, apparently. So what we'll do is we'll take this cartridge apart and see what we have to do. Okay, so here's my little Jinx cart in front of me. So what we want to do is we want to open this, and generally speaking, these things are held together with clips, but there is a screw right in here under this label. So what I want to do is I want to remove this label. I need to remove the back label as well, so that I can get at this screw and take this cartridge apart. And I'm going to use a hairdryer to do that because I don't want to damage the label. Aha! Okay, now, so that's after taking that off fairly well. We'll do the same thing for the back one. See if that works too. And they come right off. Okay. Now, so that really didn't take long at all. That's unbelievable. It came off really, really easily. It's got a little PAL sticker here on the back, but what I'm going to do is remove this screw and we'll see how it comes apart after that. Okay, that's not the right screwdriver. Okay, here we go. This one fit it? It fits it better. There we are. Okay, one little self-tapping, looks like a wood screw, keeping that guy together. And to open this, I can see clips. There's a clip in here. I think it's like the, I think it's an awful lot like the Atari 7800 cartridge. I think brute force and ignorance. Oh no, not even. There we go. Okay, what have we got inside here? All right, so now, so after taking this PCB out of the case, what we see is that I've got a Type 8 type PCB here. That's what this Jinx PCB is, because there are 8 different types of PCB, in fact, and this is one of the more complicated versions because it has 5 ICs on it. So what we have are 3 logic chips, and we have a ROM chip up here on top, which is the guy that holds the video game on it. And then down here on the bottom, we've got an 8 kilobyte SRAM. That's what we have. So that's static RAM down there on the bottom. So what I'm going to do is, I'm going to remove this and I'm going to remove this. And I'm going to put sockets on them. And that way, depending on what game I'm using, I can program up the chips differently and whatnot. And this guy here, I may or may not need for some games. So we can fool around that kind of way and see what the heck we're doing. So we'll start here. This here would be pin 1. I think that's it. It's just this first one. Yeah, it's this. Okay. This one here is still Yay! There we go. One pin seems to be... there we go. That's that fell out. Okay, so I'm after removing both chips. They're after coming out real easy. Now, what I want to do is I want to insert this 32 pin socket into this 28 pin position. So what I need to do is I need to put it in so that these 4 pins here, the pins that would correspond to pin 1, pin 2, pin 31 and pin 32 aren't actually lined up with any holes, which means that they're going to be jutting out over the edge here. But the problem there is that this capacitor and this resistor here are in the way. When that goes down there, they're in the way to let me push that in flush. So what I'm going to have to do is remove this capacitor and remove this resistor and place them around on the back side of the board. So that's what I'm going to do for now. And then I look at popping this guy in because there's a few modifications need doing to that as well. There we go. Done. And dusted. Okay. Because we want to join pin 1, pin 31 and pin 32 together. And then we want to bring them out to this point here because this point is 5 volt. So that's what we're going to do there. Right, so as I was saying, what needs to happen is pins 1, pin 31 and pin 32 need to be joined together. So I took a piece of red wire and I joined the 3 of those pins together and left the red wire just trail out from the socket. Then pin 2 on the socket needs a little piece of black wire joined to it because that's going to go to a ground point on the board. So once I had all those pins soldered up to little pieces of wire that they needed to be soldered to, what I did was I put a little bit of tape on the board to prevent those pins that don't actually have any holes to go into from shorting out on the board itself. And then I just pushed the socket down into the board where it should go. Now it doesn't sit flush against the board, but the pins are poking through enough that we can actually solder them in place. So I soldered them in a little scout ways, but it should work away just fine. Once I had that done, I took the red wire that I had soldered earlier and I soldered it to a 5 volt point on the board, and the black wire that I had soldered to pin 2 I soldered to a ground point on the board. And then I just checked with my multimeter in continuity test mode to be sure that I hadn't shorted 5 volt to ground, because that would be disastrous. Okay. And that was that part of the mod done. The final thing really to do was just to put a socket on for the SRAM, and with all that done, well, the next logical step is to check and see I haven't broken the board. Okay, alright, so it's time to see if this cart is still working after the hell that I put it through. So what I've done is I've put back in the original chips that I took out of it into their sockets there. I've got the static memory, and I've also got the original EEPROM. So the Atari is set up here, it is working. If there's a problem with this that it doesn't work, it's because I've damaged the board in some way, shape or form. So what we're going to do is we're just going to simply plug it in and we'll see if it works or not. So really the only difference is I'm after socketing those two chips. That's it. There's no reason why it shouldn't work. Good. It seems to be working. Anyway, it seems that I haven't broken anything for the moment. So yeah, I'm satisfied enough. That appears to be working to me. So I think the next step, really, what we should do now, as this board is configured for Jinks, is I'm going to find a bunch of ROMs off the internet. I'm going to select Jinks and I'm going to program it onto a ROM chip that I have, and we'll see if that programmed version of Jinks works with this card. If it does, then again we're on the right track, and what we will do is we'll see if we can get another game to work with it as well. So we'll go do that right now. Before we go any further, there's a little thing that's kind of important to know about ROM chips. There are two standards on these 128 kilobyte ones. There is JEDEC and non-JEDEC type chips, and what it basically comes down to is the JEDEC type chip has pin 2 is address line 16 and pin 24 is output enable, and that's swapped around on the non-JEDEC type. You have pin 2 is output enable and pin 24 is address line 16. That is really the only difference. Now, for some reason, and I don't know why, the Atari 7800 uses the NON-JEDEC type. And that just happens to be the very type of chip that I have. I have a couple of M27C1000s, which are non-JEDEC, pinout like this, 128 kilobyte chips. So that's what I'm going to be using in my Atari. Now, the programmer I have, which is the TL866CS, isn't able to program this type of chip. Or, well, technically it's not supposed to be able to program these type of chips, but there is a way around it. So what I've done is I've built this little adapter, which is two 32-pin sockets, dip sockets, sandwiched one on top of the other, which does this pinout thing to switch it around from a non-JEDEC into a JEDEC type of pinout. And what we do is, once we have this M27C1000 plugged in here, in the programmer, we tell it that it is a 27C1001 chip, and it will actually program it. So you will see me plug in one of these chips into one of these and programming it, and then this chip plugged into the Atari 7800 cartridge without any socket. That is the reason why. So that's what I said I would explain to you. It just makes it a little bit clearer, and this is very good to know, because I remember when I was making my Atari 2600 cartridge, I wasted a lot of time because I didn't know this stuff. So there you go, on with the video. Now, so here I am back in front of my PC. So I'm after going on the web, I'm after finding a whole library of Atari 7800 ROMs, and I'm after downloading those. So what I want to do is I want to use this Mini Pro software, which goes with my Mini Pro programmer here for programming chips. I want to use it to see what the contents of the ROM files are. And there's a good reason for that. So what I'll do is I will open my Jinks ROM file here, the PAL version that I have. We'll say OK. And you can see all of the data here that will be programmed onto the chip when we program it. But you see here at the very top, it says Atari 7800 Jinks PAL, and then actual cart data starts here. Now, the original ROM from the Atari 7800 didn't contain this portion of code. This is what they call a header that's used to give emulators and that kind of thing information. So it tells it what system it's for and also what game it is, and that way it can, using configuration files and whatever, set itself up to run that game. But if I program this onto a ROM chip and stick it into an Atari 7800, it'll balk as soon as it sees this. So what we want to do is we want to remove this portion of code here, so we're just programming the code that the Atari 7800 actually wants to see. So we see that the real data here is starting at address 80. So what we will do is we will file and open, and I will open the Jinks one again here, and where it says from file start address in hex, we're just going to tap in 80 and click on OK. And now you'll see that that little portion with the Atari 7800 and the cartridge data starts here is gone, and we've just got the actual code that the Atari 7800 is looking for. So there's a good chance that this should work for us. So what I'll do is I will plug my programmer in here like this, and I've got this little chip here that was blanking inside in my EEPROM blanker there, my little UV light thingy, and I will put that into its little socket here. There we go. And I will plug it into the programmer like that, and I'll just check and see that it is indeed blank. There we go, good, it's blank, and we'll program it and go see does it work. Okay, so I'm back in front of my Atari again. This time I have my programmed PROM with Jinks on it, and hopefully it'll work. So we had to remove the header on the file, as you saw. I just flashed it onto the chip. pushed it into the socket and we'll see what happens. So we insert in here and power on. It's working as well. So okay, this is very good. It means that at least what we're doing is right. We can get files, we can remove the headers the way they should be removed, we can program them onto ROM chips, and the ROM chip is accepted by the PCB here, the cartridge PCB, and read by the Atari as a real game ROM. So this is good, as I've said about 1,000 times, but it is. Because what it means is that hopefully we should be able to, with very little modification now, get pretty much any game to work on this cartridge. So I think the next thing that we'll do is we'll blank that chip and we'll see if we can program Donkey Kong Jr. How about that? Because that's the game I would like to get to work on this. And we'll see what happens with that. So on we go. Almost 2 hours has passed since we first got this to work with the version of Jinks that we downloaded off the internet and programmed ourselves. And since then I've been fooling around with it, trying to get other games to work, and I've had success with some and none at all with others. And unfortunately, Donkey Kong Jr. is one that I can't get to work on it. Now the reason for this is that the Atari 7800 has different forms of bank switching that work with different games. And I said before that this was a Type 8 board. Actually, there are 9 types of board for the Atari 7800, and this is a Type 9. And it's good in a way because it has 6 little pads on it that can be shorted in different ways in order to give us different types of bank switching. And that's partially the reason why I can't get some games to work on this. Some of the boards have 8 pads, so I'm missing 2. So all the forms of bank switching aren't available to me. Well, just yet anyway. I'll dig into it deeper and I'll figure it out. But for the moment, there are a couple of games I can get to work on it. Now, what I'm going to do is I'm going to show you a couple of games that I managed to get to work from a Type 7 board. And that's the reason why I've removed the SD-RAM chip here. It's not needed in a Type 7 board because the games don't need it. So what I'm going to show you is, first off, that it works with a different game, because that's the whole point of this thing. And the game that I programmed on this is Dark Chambers, which is a game that looks very, very much like Gauntlet from back in the arcade. So when we power it on, we get asteroids, which we shouldn't get. So hang on 2 seconds. There's something after going a little bit wrong. I wasn't plugged in right. That's what went wrong. There we go. So when we power on, we get Dark Chambers. There we go. So I think the screen on that looks nice. I think it's a nice little, see, you've got a doorway and you've got 2 eyes looking out at you, like this kind of ominous, bit scary type thing. Anyway, like I say, this game, we're entering level A, is an awful lot like Gauntlet. You can play 2-player in this one too. And we can shoot here like that. The second button doesn't actually do anything that I can see. And we're shooting these little guys, if I can actually aim at them. There we go. And we're running around trying to collect keys, and we're collecting potions, and we're collecting energy, and we're doing all that kind of thing. And basically, yeah, we're clearing out dungeons and whatnot. So that's that game. Now, I also managed to get the game Cracked to work on it. So I'll show you how easy this is to do. Now, Cracked uses the exact same bank switching routine as Dark Chambers does, so I don't have to go soldering anything on this board in order to play it. So I just remove that chip and I put in this one, which has Cracked programmed onto it. And if I push it in properly this time and power on, it should come up with the game Cracked. There we go. So I've got 3 levels. I've got easy, normal, and insane. So we'll start with easy. Now, I'm not sure about this game. I've given it a little play. I don't know if I like it or not. It's a kind of a shooty gun thing with what you call it, with the joypad, which is kind of impossible to control. So these guys are trying to rob our eggs. We can catch them with the B button, the eggs, and we can put them back into the nest, and we're trying to shoot the birds as it goes. But anyway, that's the game on it. So as you can see, it is possible to pretty easily mod an Atari 7800 cartridge and to get it to work with different games. Now, I will be coming back to this because what I need to do is I need to put a little bank of switches onto the board so that I have 8 switches available to me that I can easily switch. And that way, no matter what game I program onto a ROM, I can plug in and I can switch the banks, because I'll be honest, I damaged the board a little bit doing it. I lifted one entire pad on the bank switch 2 fella there, which could have been disastrous, but I managed to sort it out with a bodge wire. But what I need to do is I need to put a little bank of switches on the back, and that way we should be able to get it to work with all games. So I will be coming back and having a look at that. So that's pretty much my episode for today. It's been a kind of a short one. I think it hasn't taken me long to make it, and yeah, I think it's short, I don't know. But what we'll do is I'm going to give you a Star Wars joke again today. That's what I'm going to do. So tell me, why did the Star Wars movies come out episode 4, 5, 6, 1, 2, 3? Because in charge of scheduling, Yoda was. There you go. That's another one for you. They're getting worse, aren't they, every time? I think they are. But maybe that's the point, huh? Anyway, look, what I'm going to do is I'm going to leave you with that. Again, as always, like, subscribe, tell your buddies about it, stick a comment down below, and in the next episode, I'll be doing something else. So until then, we'll talk to you all very soon. See yous, and bye-bye.